just one loose end that I wanted to tie up from video one before I go through the answers was just around these class definitions. And one thing that some of you may have noticed is that there isn't a need in the class definition to supply the constructor. So unless you're asked to specifically do so in the exam, then don't worry about that, because obviously every class will need a constructor to enable you to create an instance of it in the first place, and it's usually named after the class itself, as hopefully you're aware of. So unless it specifically says so, then don't worry about including one in your class definitions. If we went back to that first example on class 1, you could argue actually that this method here is very much or could act as a constructor for this class, were it to have the same name as the class. Okay, so I think generally the approach is that they'll probably ask you just to create it as a procedure that sets the values, but they won't ask you to include a constructor that's named directly after the class. Certainly the examples I've seen that's been the case. Anyway, back to the questions. So this is very similar to the kind of questions that you'll get in the test, and in this particular one the main focus is on an inheritance relationship between media file and then we've got is it video file and music file as the subclasses that are inheriting underneath that, so you can get the feel for a typical setup for a question. So should we have a look at the answer and see how you got on? So the first one was just definitions, wasn't it, in terms of what is inheritance and what is meant by inheritance. So you can check that against your definitions. Notice also a different term for subclass and superclass, parent and child, the child being the subclass, parent being the superclass, so just another term for the same thing. And just look for the language and how you explain these definitions, because that is quite an important skill to have. Then we have the actual diagrammatic representation of the classes, and notice again it's an inheritance relationship, so we have the two subclasses inheriting from the media file, and the denotation of that with the hollow arrow. So hopefully that was okay. Then we've got another definition, I think, haven't we? Another definition. What's that to do? Is that to do with polymorphism? Let's see. Oh yeah, so the ability to override methods and what's meant by that. So yeah, polymorphism, and the answer and how that's explained there. And hopefully you've had a chance to kind of practice that with some of the exercises you've been programming, know what is meant by that. I'll notice that polymorphism did get credit as well. And then we have the actual key one that I was hoping for you to see how close you are with this as a right answer. So you have to do the class definition of the music file class. So the music file class, which is inheriting from media file. So you can see straight away the name of the class and the fact that it's inheriting from the media file. The tricky one maybe in this question was to ensure that you override the play file procedure, which is going to need to be implemented differently within the music class. There's not a huge amount of information in the question there to help you identify actually, so well done if you did get that. It kind of makes sense if you think about it. Play file, well, if you're playing a music file, that implementation is going to need to act differently to how a video file implements it. So they're going to need their own methods for being able to implement that particular behaviour. And then just notice again that standard thing, which I'm just trying to get across here in terms of the functions mapping directly to the individual attributes of the class, in terms of being able to retrieve those attributes and use them elsewhere in the program if we need to. Good. And the other key thing, I guess, just to point out in the question here as well, in case you missed it, this class does not have procedures to set the values of the variables, so that's quite important there, because that's saving you having three procedures basically, which are to set the individual values of these particular attributes. Okay, so hopefully that's tied that up. And again, no constructor needed in this class. Okay. What do you get about? So marks for the correct header, so that was worth a mark, and then spotting that you could that method would need to override within the class itself, and then getting the right functions, so just matching them up to the attributes, and also here the data types and the attributes being listed as well. Okay, so that's where the credit lies. So that's very similar to the sort of questions you can expect to get in the test. Other things that you need to be aware of and revise for the test, well, class diagrams and understanding the relationships between classes. So it's not just inheritance. So like we can see here, the library book is a subclass of book in this particular instance, and we've got some more inheritance here in terms of a reader inherits attributes and methods from a person. But you should also know what these different symbols represent in terms of the relationship between the classes. So we've got aggregation with the hollow diamond, and composition with the black diamond. Shape. You also need to be aware of multiplicity and how you use that to describe the relationship. So for instance, one book might have many pages associated it. So within it, so it sounds similar to kind of like database relationships, but the notation is different there, and you do need to know about the different ways that you can denote the relationship between classes. One relationship type that is not on there is just a straightforward arrow from one class to another. So sometimes you might have a straightforward arrow which just means there's an association between the classes. They might interact with one another, but it's a very loose relationship, an association relationship, and would probably have that relationship denoted with some multiplicity attributes as well. Okay, so make sure you know your symbols, and the key thing here is to learn the definition. So what is a composition relationship? What is an aggregation relationship? What is an association relationship? And of course inheritance, which has been the primary focus. Just one key thing from a programming point of view in the exam. It's my understanding that in the exam you will only ever be asked to program an inheritance relationship. You won't be asked to create composed classes or aggregated classes, is my understanding. Okay, so this was a program exercise which I think we'll probably come back to in class, but the idea with this was actually to try and actually make some sense of these class relationship diagrams in a practical sense by actually implementing them in code. So in this case, we have an employee class which has an aggregation relationship with an insurance policy and a composition relationship with the address. Okay, a composition being the strongest, closest form of relationship between a class, and you can see that actually within the constructor of an employee object, we create a new address object as well, which is set when an instance of an employee. So that relationship is very tight. If we lose the employee, we lose the details of the address and the city. Well, you'll notice up here we have an instance of another class, the insurance info class, but we can create that instance outside of an employee and assign the details into this particular attribute. Therefore, if we lose the employee, we don't necessarily lose the insurance policy. Okay, so quite really hard to explain and try to describe in a video. So I think we'll come back to that. It'll be interesting to see how you found the actual programming task and see if you can sort of begin to see that connection between how these relationships are implemented. Okay, and then the final thing just to be aware of is this lesson on programming principles, OOP programming principles. Now there's three. The first is the easiest one to sort of understand and comprehend. It's the idea of encapsulation, and you've kind of got familiar really that when you sort of do these class definitions, you set your attributes to private. You should know what that means in terms of the accessibility of those attributes, but generally it's good programming practice to set the attributes of a class to private, and then you have your public facing methods, and only through those methods can you actually interact and access the private attributes of a class. So it's it's seen as a good principle for programming in OOP. Again, you're not going to see this on every single class that you ever come across when you're working in an OOP, but where you can, it's definitely a good method to use, encapsulating the class, basically ensuring the only way that you can control and access the data variables within it is done through defined methods within that class. Okay, that are made available. So sort of a security first approach to programming, I might say. Principle number 2, of course, is favouring composition over inheritance. Now, so this is getting quite involved now. So you really need to have understood some of the previous programming exercises you've done. This exercise that he demos in the video using Python could well worth be an exercise for you to have a go at doing in C#, so that you really kind of understand what's going on. But yeah, generally inheritance is not as flexible as composition, and you need to be able to explain the benefits of using composition over inheritance in terms of having more flexible, loosely coupled code, which is more reusable and safe as well, I guess. Okay, so the key thing here is that you're not going to be asked to implement that in an exam in terms of programming, but you might be asked as to why is composition favoured over inheritance. So read around that and see if you can get the understanding, but that's going to take a little bit of time to grasp, I suspect. And as is interfaces as well. So interface is another good kind of programming principle for OOP. So understanding what an interface is and being able to explain the benefits of implementing one is what you need to be able to do in an exam context. You're not going to be asked to program one in the exam, okay. Specifically, unless you're not going to see that specifically in the exam. So that's everything for the test on OOP. So key things: your class definitions, understanding the makeup of a class, understanding the definition.